Unlike flat plane geometry or unlike spherical geometry, which we're more familiar with, sea slugs embody something called hyperbolic geometry, which is a negative curvature. You sometimes see this negative curvature in really common things like lettuce leaves, also corals. So what I'm really interested in looking at is being able to actually measure the 3D curvature on nudibranchs. And have any of you guys ever 3D printed a sea slug? No. Okay, because I was like, if anyone raises their hand, I totally did not network right this weekend. So what I'm interested in doing is creating a system to 3D image these guys, because what is really unique about these sea slugs is that, see where those arrows are all pointing into that undulating line? These guys eat things like sponges, steal their chemical defenses, and then put them into their own tissues, use them for their own defense. These guys evolved from marine snails, and they were able to lose their shell basically because they can steal these chemical compounds. And now the funding side of this is that these chemical compounds are unique and being used for cancer and HIV research. So what's really interesting is being able to kind of look at the shape of the sea slug and compare it to the different types of secondary metabolites, these defense chemicals in them. So how do you do this, right? I've taken some pictures with the auto montage we have here at Cal Academy, and you can kind of see that I can get like a pretty good idea of like the number of undulations, but it's really hard to actually measure the hyperbolic plane. So there's a program out there called 123D Catch, and if I was really lucky and rich and sea slugs were as big as I was, I could go bring it to Autodesk and plop them down in that like 100 camera zone, take their pictures, upload it, and create this 3D mesh. And so that's what I'm going for. However, they're really small, they're about 1 inch, the genus that I'm studying. And so what I'm trying to build instead is some sort of contraption that scientists can take into the field and basically 3D image marine invertebrates while underwater. And the thing that makes this particularly difficult here is that they're wet, they're slimy, and you have to put your camera under the water, and I'm out of time. So basically, if you guys have any ideas, I'd be really excited to know. This is going to be like the hack that will continue until I get my master's degree. So 3D imagers, hit me up, and thanks to everyone.